this is our logger functionality, playback functionality. So we save several sensors from the ATLASCAR, and then we save them to files, and we can play the data back respecting timestamps, so that we can do time synchronization, and also the data is entirely registered geometrically. Here you see a typical playback of a log. So we have several messages which are represented by the bands, the colored bands, and you see here this is a camera message, and then we have laser messages. This is time along the log. So if we zoom out completely, you can see that the log has 242 seconds, and if we zoom in, we can see that different messages have different paces, frequencies. Because, for example, the cameras here are being published at a much higher pace than the GPS, which gives us almost one message per second, only one message per second. So if we play back the data, it will start sending messages to all the other processes. And if we look at the GPS data here, we can just turn on the process that reads the GPS data, and you can see here where the car was, latitude, longitude, and so on, at that specific time of the log. We can then take a look at the images from the cameras, which are here. So this is images occurring at a particular time of the log. This is going very fast. It's now 4 times faster. I can just go back to 1 and you will see the real time of the log. So this was the frame rate that we had. We are saving at lower frame rates than the cameras actually have in order to save space, because a typical log like this can have around 40 or 50 gigabyte. We generate around 1 gigabyte per minute of information. We can then look at some other cameras. For example, we can take a look at the stereo camera. This is the image from the stereo camera, and this publishes also, apart from the image, a 3D point cloud, which is given by the stereo map disparity correspondence, and it evaluates the distance. And we can try to take a look at it here. So what we are looking here is at the 3D window. So we can just navigate around, go forward, go backward, zoom in, zoom out, and move around. And this is the environment around the car at the given instant. So you can see the points that have texture are given by the stereo camera, which I can turn back on. Here it is. And all the other colored points are given by one of the 4 lasers that we have. It's hard to visualize without seeing the lasers. I can tell you that these light blue and orange dots are given by lasers placed here and here on the car. We then have some other 2 lasers on the roof of the car, pointing towards the road, pitch it down. And this is a good example here. You saw from the image that the car was pitching around because the road had lots of holes and bumps. You can see here from the images that the car actually bumps up and down. And if we turn on the subscriber, this is a simple example. It shows a cube. This is the inertial measurement unit log subscriber module, and what it shows is the cube moving around when the inertial measurement unit detected some accelerations and movements of the car. So if we actually play back the data here, you can see that the cube moves around a lot, because this was a very bumpy region of the road, and now it's stabilized because we're stopped, and it's turning now because of the compass we are turning somewhere else. And these are typical We'll just reduce this one so we can go back and see this. These are typical logs that we have from the region of Aveiro and some other cities in Portugal. And what we actually do here is register the all data, visual and three-dimensional laser, in a single reference frame. So you can see, for example, here that there is a car there on the image, and you all are also seeing on the same position a laser measurement of the car. And this registration is all entirely done when you get the log.